Hey guys, this video is going to be about solving rational equations. Now, there's a couple steps here. Okay, the first thing that we want to do is we want to be able to get a common denominator on each side of our equation. Once we have that, we're going to just set the numerators equal to one another and then solve for whatever our variable is. We have to be careful about extraneous solutions here. We need to make sure when we get our solutions, we plug them back into the denominator to make sure that that value isn't going to make the denominator equal to 0. If it does, we're going to throw it out. Okay, it's an extraneous solution. If there are no other solutions left over, that just means that there is no solution to that equation. So we're going to just look at a bunch of examples. Okay, now remember, we want to get a common denominator on both sides. So that just means that I need to multiply the right side by x minus 6, and I need to multiply the left side by x. So if we do that, we get 7x over x times x minus 6 I'm going to write this a little differently. (7x over x times x minus 6), and that would be equal to 4x minus 24 over that same denominator of x times x minus 6. So once we have a common denominator, we don't really need to look at the denominators anymore. If these two rational expressions are going to be equal to one another, and if they have the same denominator, that means the numerators must be equal. So we're going to just make a new simplified equation with only those numerators. And at this point, this is just a basic Algebra 1 equation. We get our x's on one side. We divide. We find that x is equal to -8. Now, when we plug -8 into our denominators above, all we care about is that it's not going to make them equal to 0. So they're going to be negative numbers. We're going to get a -14 and -8. Neither one of them is 0, which means the solution is good. Okay, so another one very similar. We need a common denominator first, so that means that this side needs multiplied by 3. This side needs multiplied by m minus 2. So we're going to get m squared plus 3m minus 2m minus 6 all over 3 times m minus 2 equal to 24 over 3 times m minus 2. So again, once we get the denominators the same, we're just going to set the numerators equal to each other. So m squared plus 1m, I'm going to combine those m's together, minus 6 equal to 24. Now, since this is a quadratic equation, we're going to want to get our variable, or not just our variables, but everything to one side of this equation. And we're going to solve by factoring. Once we factor, we're going to set each factor equal to 0 and solve. So we're going to get m equals -6, m equals +5. Neither one of those values is going to make the denominator in the original equation a 0. So we have two solutions. M can equal -6 or +5. Okay, same thing. Let's get a common denominator. When we multiply this out, we get y squared plus 5y over 3 times y plus 5 equal to 3y plus 24 over 3 times y plus 5. So just like the previous ones, since the common denominator is there, we're just going to set the numerators equal and solve. Again, we have a quadratic equation, so we're going to factor. But before we do that, we need to get everything to one side. And this is going to factor into y plus 6 times y minus 4. So now we can set each factor equal to 0 and solve for y. So we're going to get a negative 6 and a positive 4. Neither one of those values is going to make the denominator equal to 0 in our original equation. So once again, we have two solutions. All right. So let's look at one where the left side here isn't a single rational expression. Before we can proceed with solving, we need to simplify this left side so that it's a single fraction. Now, we need to get a common denominator to make that happen. So we need to multiply this one by 2, this one by k, and we get 6 over 2k minus k over 2k. So now this becomes 6 minus k over 2k. Okay, but if I want a common denominator, I'm going to need to multiply this right side of my equation by 2. Oh, 24 should really be here. And now I'm in a position where I can set my numerators equal to one another and solve. So we're going to get 6 minus k equals 24. Let's subtract that 6. Divided by that negative 1. And we get a single solution here of negative 18. And when we plug that in, it's not going to make any of our denominators equal to 0, so it checks out. So sometimes you'll need to do some simplifying like we did here, where on the left side we needed to combine those together to make a single rational expression. And that's what we're going to see in the remainder of these problems in this video. Okay, so again, that left side needs combined together. Now, I'm going to have to multiply this piece by p minus 2. Okay, I don't have a lot of room to do that, so I'm just going to rewrite it. Okay, there we go. So I can combine those numerators together now. So p plus 2p minus 4 all over p minus 2. And I notice that this denominator here is a difference of squares. I'm going to go ahead and factor that because I noticed that I'm going to get a common factor of p minus 2 on both sides. So to get that common denominator I need, I'm going to have to multiply this side by p plus 2. So it's starting to get a little messy here. Let's rewrite this. So I really have p plus 2. I'm going to combine my like terms here. So we would get a 3p minus 4. And now that I have that common denominator, I can rewrite this equation just with the numerators. I'm going to FOIL the p plus 2 times 3p minus 4. And here we go. So now at this point, we just need to simplify and move everything to one side. Since it's quadratic, we can factor and solve for our solutions here. So let's see, we would get a 3p squared plus 2p minus 16. Since there's a leading coefficient of 3, when we factor this, we really need to find two numbers that multiply to negative 48, because we need to do 3 times negative 16 and add to positive 2. So let's see here. Those numbers are going to be a positive 8 and a negative 6. So now we got 3p squared minus 6p plus 8p minus 16 equal to 0. We're going to factor by grouping. So p minus 2 times 3p plus 8 are our factors. So now we just need to solve here. P minus 2, if we set that equal to 0, we're going to get p equals positive 2. And if we set 3p plus 8 equal to 0, we get p equals negative 8/3. So we need to check each of these. When we plug them in, do we get 0? The answer is yes. When I plug 2 into the denominators, I get 0 here and 0 here as well. So that's not okay. We can't have 0 in our denominator. It's fine to have 0 in the numerator, but never in a denominator. So we have to throw out 2. The negative 8/3 is still fine, so we still have a solution here. There's just 1 instead of 2 like we thought. Okay, another one where we have to get that left side combined first. Notice that this left side, the denominator here, has a GCF of 3, and if we factor it out, it reveals a w minus 1 like we already had here. So it's pretty easy to get a common denominator. We just need to multiply by 3. So we really have 13 over 3 times w minus 1 minus 3 over 3 times w minus 1. And then we know we want to get a common denominator. So here's where it kind of gets tricky. I know that this right side is going to need a w minus 1. So I'm going to go ahead and multiply this by w minus 1. It's not going to give us our full common denominator, but it'll help us get part of the way there. So let's clean this up a little bit before we move on. On the left side now, I can combine these to make 10 over 3 times w minus 1. And the right side of my equation now is w squared minus w over 9 times w minus 1. So now to get that 9, we need to multiply this side by 3. So now we have 30 over 9 w minus 1 equal to w squared minus w over 9 minus 1. We have a common denominator, so now we can set those numerators equal to one another. And then we are going to need to factor here. So let's get everything to one side. Okay, and this is going to factor into w minus 6 times w plus 5, which is going to give us two solutions. It's going to give us a positive 6 and a negative 5. Both check out. Neither one of those makes our denominator equal to 0. All right, so this time the right side needs a common denominator. So we're going to have to multiply this 2 here by x plus 3 over x plus 3. So we have x plus 6 over x plus 3 equal to 2 times x plus 3 over x plus 3 minus 5x plus 12 over x plus 3. Now, I notice that we already have a common denominator across the board here. So we can just set the numerators equal. We really just have x plus 6 equal to 2x plus 6 minus 5x minus 12. So now we have a basic algebra 1 equation again. Let's combine like terms on the right side. Move our variable to the left. Move that 6 to the right. And we find x equals -3. Here's the problem though. When I plug that in to my denominators, I get 0. And since this was our only potential solution, that means that this function, this equation I should say, has no solution. So let's look at one final problem. Okay, that right side needs combined into a single rational expression. So it's going to need multiplied by c minus 4 over c minus 4. I'm also going to factor this denominator, so hopefully there's something in common between the two sides here. So I'm going to combine that right side. C minus c would cancel, and then we're subtracting a -4, so we really get a +4 here over c minus 4. And to get a common denominator, I need to multiply this side now by c over c. So we're going to get a common denominator after that, so we can set the numerators equal, which leaves us again with a pretty basic equation to solve. Let's subtract 3c from both sides. We get -2 is equal to 1c, so there we go. There's our answer. All right, guys, I hope you found this video helpful. Don't hesitate to reach out and ask questions, and I hope you have a great day.